Hello, everyone. Welcome back to the second video in the series of measurement system analysis. As I told you in my first video, the first video was about trying to give you some tips on how to get the most out of a GR&R study. And in this second video, I thought of addressing the second most important MSA analysis that we do, which is the linearity study. Linearity, in my opinion, is another very, very important MSA study, particularly more so when you use long-range measuring instruments. Typically, we have examples in different sectors. When we use maybe a height master in the case of auto component manufacturing industry, or a caliper, or a micrometer, or a long-range dial indicators. But more importantly, in recent times during my consulting, I realized that the importance of weighment, especially when you deal with organizations in the chemical sector, pharmaceuticals, tire industry, for example, the very first process talks about weighment and then blending or mixing or whatever you call. So weighment is so important, and most of the areas when we went through the Gemba analysis, we found that you use a weighing balance where you probably use the same weighing machine, weighing balance, the load cell, and the sensor and indicating devices, where you probably weigh about 100 kg and also 5 kg of different ingredients, different chemicals, and then it gets into for blending. So in these examples, particularly with respect to some ceramic industries or tire industries, or making chemicals, pharmaceuticals, for example, weighment is very, very important. And that's the reason why I used to always stress on this study, linearity, when I consult those companies. Linearity is another important MSA tool, which I think, again, as I was saying in the previous video, many times it's being used more as an activity just before the audit, as a tick mark activity, as you call it. Whereas, linearity also, like the GR&R study, which we discussed earlier, is another important study which gives you a lot of insights. It's again a CT scan kind of a report where one linearity study gives you a lot of insights, particularly the graphical outputs that you see in softwares like GaugePack or other softwares. You will be able to analyze and see what improvements can be done to further improve the measurement reliability. So that is why here again, I use the same thing. Again, there's a wonderful example that is mentioned in the MSA 4th edition manual, the manual released by AIAG. Like the GR&R example, the linearity example that is mentioned in the manual is also a very, very good example. A right example which will actually give you ideas about how we can get the most after doing a linearity study. So without wasting much of your time, so I'll straight away get into it. This time, I'm not going to get into the GaugePack software. I've already done the analysis and picked up all the outputs. So I'm going to run through how I got the best linearity, how I improved the linearity status of the measuring instrument. So I use the same example of the MSA manual. So let me share my screen so that you'll be able to see the linearity study. Right, so this is my presentation, short about 4 or 5 slides on linearity with GaugePack software. Again, I prefer the software primarily because it gives you very good visual indication. I mean, as we all know, some of you probably, being in black belt or a green belt will be aware that this is nothing but a simple linear regression is what that we do when we do a linearity study. But quite often, people who do linearity study are not exposed to tools like hypothesis or regression, and because of which their understanding of the what to do after a linearity study is always a question mark. And when we drill down more about what have you done, etc., they come back like the same thing that I was sharing with you in my previous video on GR&R. People, if the linearity is not okay, after maybe 2-3 days or after a few hours, they do another linearity study, and they probably make sure with that Excel template that their linearity is okay. So nothing really improves in the process. So that's the purpose of this. So that is the reason I always use, I prefer softwares like GaugePack, which is, in my opinion, a software which can be used even by a non-Six Sigma belts. You don't have to know more about regression. Of course, knowing more about it is actually good. But in the event, if you're not aware of this, traditionally what happens in the industries that I work with, where the guys who do linearity study are not exposed to regression, vis-a-vis similarly when they do a bias study, they're not exposed to one sample t-test and things like that. So this is the challenge, and that's where softwares like GaugePack will help you. So I'll quickly run through it. This is the highlight of all the 3 slides that I have. So I'll quickly run through the MSA example, so that gives you an idea about how we went about it. So let me move the slide now. Yeah, this is the first output that you get from an MSA manual. So if you look at the AIAG MSA 4th edition manual, and if you look at the linearity data that they have, this is the example. So same MSA manual example on linearity. So you'll probably see a very similar table in the manual. So if I put this data in the software, in the GaugePack software, then it immediately, and I press the button compute, it immediately does the analysis and shows me 2 big red lights. I mean, small, it's pinkish here. I mean, it gives you a red signal, I would say. So what it is tell you is that the T slope, which is TA, and the T intercept, which is TB, both are significant. So that's what this output tells you. So that is why I say softwares like GaugePack helps even a non-Six Sigma professional or somebody who's not very tuned with regression can still use and get the most out of a linearity study. So on the right-hand side of your screen is the graphical output that GaugePack gives you for the linearity plot. So it has your range, measuring range at the y-axis, the x-axis, and bias in the y-axis. And you see there's a slope. So T slope, and which is also significant, and the T-intercept is also significant. So that's the basic thing. So the whole idea is that what do we do from here? So this is your first output from the MSA example. So the outputs that GaugePack tells you is both slope and y-intercept are significant, and it shows you a red signal that the gauge fails the linearity test, right? So what do we do next? With this, what do we do? So this is where this video will help you when you actually do a linearity study. It is not just about the answer. As I always say, all MSA study is not the end, it's the beginning. It's a scan report that you have got. Now we need to act on it. So what do we do next in this case? Of course, this is what is the explanation of this video. So what I've done here is, the first iteration is, so if you looked at it, you had slope also significant, and you also had the y-intercept significant. So what we do was that we looked at the bias values. So at the top, you have those bias values. So these are the bias values. So let me go to the previous slide. So these are the bias values. You have at 2 units. So, okay, so this is the range that is given, 2, 4, 6, 8, 10. It could be 2 mm or 2 kg. I mean, it's not mentioned in the manual, so let's not worry about it. So it's some measuring system which has a range from, let's say, 2 units to 10 units. And that's what they've done. So 2 units, there is a positive bias of 0.49. And similarly, if you go down at around 10 units, there's a negative bias of minus 0.6, right? So that's what is actually creating the slope problem. So first thing what we do was, the first iteration is, I thought, normally what happens is you call the service engineer or the calibration technician or the supplier of this instrument to come and show you how to reduce the slope. You should give them this picture so that they'll be able to work on. And what they will actually do is they'll actually reduce the slope. So as you see, what they've done here is, so they've given some compensation at the 2 unit level, so that the bias is now significantly reduced. Okay, it was from 0.4 in the earlier stage to 0.07. Similarly, at 10 millimeters or 10 kg or 10 units, whatever it is, so they've reduced the negative bias, the impact, the amplitude is reduced. So the positive bias at 2 units and the negative bias at probably 8 and 10 units were compensated. And when we do that, when we change those values, of course, in this case, I just changed the values because it was just the MSA manual examples. But in reality, we actually work on the gauge. We call the service technician to say, hey guys, why don't you reduce the bias at 2 units? I know, but there's a positive bias. That's what I'm getting. So reduce it. And at the 10 units, there is a negative bias, so increase it. So when you do that, what happens is your slope, the significant slope has been reached. So now when I compute it with gauge pack, it gives a green signal on slope. So the T slope is now green. So which means slope is okay. Slope is not significant. T slope is not significant. But I still have TB is significant. So the gauge still fails the linearity test. Okay, the gauge is still not okay. Although I have fixed one problem, I need to fix another problem. What's another problem? So another problem is more to do with the range values that you get. So if you look at the range values here, look at the range values. At two units, you have a range value of only 0.15, whereas at 4 units, it is 1.3. At 6 units, it's 0.7. At 8 units, it's 0.1. That's the range. So I do about 12 iterations. That's what the manual says. 12 times these measurements was made and the range. So if you look at it, the range at 4 millimeter is the highest. And that's what graphically also it says. At 4 units, you have points which are very far away, which are really scattered. So that's what I'm going to act next. So next is I'm going to work on the repeatability. So let me move on to the next slide. So iteration 2, what I do is I work on the repeatability at 4 units. So what was very significant earlier, I have brought it to about 0.4 now. So if it is once it has become 0.4, the repeatability from 1.38 units to 0.4 units. So I brought it closer. So that's what you see in this picture. The values are now closer. And when I now say compute, both are now green. So the slope is also green and the y-intercept is also green, which means TA and TB are not significant. So this is how GaugePack confirms that this gauge is now past the linearity study. So this is the most important thing I want to share with all of you, because many times I find, be it a GRNR study or a linearity study, you always have a problem when you have that the results are not okay. What to do next is always a problem. So you try to probably, do the study again and, ask a better inspector to see or whatever you do. But the real crux is that you should see the picture and look at, there are two types of problems here. You have a bias problem and you have a repeatability problem. So first you address a bias problem and bring the slope within, slope as not significant. And then you work on the repeatability problem. Now, in this case, there are further improvements possible. If you see the repeatability at even 6 units is fairly high, right? You can further improve on this. So when you do these kind of things, your linearity of the measurement system improves a lot, and you're able to actually get a better output, better measurement. I mean, as I was referring to you earlier, we were doing a very important improvement project to get the variation of the output parameter out of mixing to be well within control. Be it a pharmaceutical industry or tile manufacturing or a tire manufacturing company. The very first operation is mixing. So we mix it and you get a compound or a mix out, and then those parameters. So weighment becomes very, very critical there. So the more better your linearity of the weighment system, and most of these systems, if you look at it, it could be very automated system, but the linearity there, so the load cell that you're using here covers a wide range. So it could run through a linearity error. So practically we have done the study, we have made those corrections, and we now get very, very good consistent quality output after your mixing. So these are, so why I'm sharing all these, live cases with you, referring to the MSA example. Again, hats off to the AIIG guys. They've given us a wonderful example, in which you can go, you can do different iterations and see how you can improve linearity, right? So hope you've enjoyed this video. So please, share your comments after you see this video. And I also request you to, send me suggestions on what other areas that you would like to have, insights like that, and what other tools, so that I will, if possible, I mean, if I have some idea, I'll be able to come up with some simple 10-15 minutes video by which, you understand the concept behind these tools. It's not, let's not use these tools in a ritualistic manner just for the sake of audit. Let's use this tool more towards, improving the quality of the product that you make, because these are very, very important tools, where the power is not, in my opinion, is not yet felt by industries, typically in manufacturing. And especially as we are talking about it in this quarter, most of the CEOs whom I have met, they're all saying that the top line is fantastic, but the bottom line is where there are problems, there are input costs going up and all that. And tools like this will actually help you to make your product more consistent. I mean, if your mix output is fantastic, you're going to reduce rework. There's going to be, the downstream processes are going to be much better capable, so that your rework and rejections, or probably you come up with a very, very premium mix or a premium product on which you get a better pricing from your customers. So everything, whether it's a GRR study or a linearity study, they finally, if used properly, will give you that extra cash in the need of the hour is to improve bottom line. So that extra cash will actually come from these. These are not studies just for the sake of satisfying an IATF auditor or a customer auditor. These are not that. These are beyond that. By doing it properly, you can actually get very good benefit out of these studies. So please enjoy doing GRNR and linearity study. Share your queries also. If you have some things, please send a note or a comment section. Then I'll share my email address. We can continue the dialogue. If you have some data and you find you need some assistance, of course, GagePack is also available on a 14-day trial basis. You can put in those data in GagePack. And if you can send me GagePack outputs, it makes it even more graphical output. So both in GRNR and in linearity, I've tried to explain to you, it's not just about math. It's not just about number crunching. It's about graphical output. Look at the graph and make your judgment. Look at the graph. The graph will tell you something very simple. You don't have to know the complicated math behind regression analysis and things like that. You don't have to worry about R-square value or what is T-slope or what is T-intercept. You don't have to. I mean, if you know that, it's fine. I'm okay with that. But if you're finding it difficult, don't worry. That's where you have softwares like GagePack, which helps you to do the right. As managers, your job is to take the right decisions based on the data that comes in front of you. Don't worry about if there is a failed linearity. You can still work on it. Don't worry if you have a high gauge R&R. You can still work on it. You can still make it work. So that's the purpose of these two series of videos. Please, look forward to listening to your comments on this video. Thank you for viewing my first video and sharing your comments. And by way of the comment section and by way of your emails, I'm really look forward to listening to your comments, to hearing your comments again. Thanks. Bye for now. This is Nanda signing off for PQSI, making quality happen since 1999. Thank you so much.